Okay, everybody, I guess we'll get started. So this is, I guess, week 2 of CISC121. So I hope to do these meetings weekly, more or less, except during weeks where you have a quiz or something like that. Let's see. Okay, I guess we can get started. So today's agenda, I have a few announcements to make. Then I'm going to talk about 3 things. Well, one thing in particular. So identity and references. So this turns out to be really important in Python. And as you'll see, if you take 124, it turns out to be very important there as well. And then I want to look at a couple of arithmetic problems. And then I'll take any questions, if you have any questions about the week 1 or week 2 readings and or notebooks. Let's see, so I'm going to try to monitor chat to see if there's any questions, but it's difficult given the number of students who are here, but I'll try to do my best. Okay, announcements. Assignment, wait, is this the right course? Hold on, this is the wrong course, I'm sorry. Not assignment 2. Assignment 1, sorry, this is for CISC124, Monday. So on Monday, you'll get your first assignment. You'll notice that the evaluation scheme has been finalized on OnQ. All of your quizzes have been scheduled. All of your assignments have been scheduled. So you can go into OnQ and see them now. If you can look at them either under the assessments tab or whatever OnQ calls it, or you can look at the weekly schedule and they should be entered into the correct weeks. The assignments are entered into the weeks where they start. Okay. I keep on forgetting to make the discussion forums, but they'll be created and opened by tomorrow. Hopefully tonight, if I can find some time this evening to work on it. And so there'll be basically a forum for each week where students can post questions. If students know the answers to questions other students have posted, I would encourage you to answer them. If not, me or one of the TAs will try to monitor the forums and post answers within a day or so. Okay, anybody have any questions about the evaluation scheme or anything like that? Quizzes are all on OnQ. They're not proctored. I'm not exactly sure how I'm going to run them, whether they'll be open for 24 hours or what, or something like that. The exam, someone's already asked about the exam. It's similar. It's on OnQ. It's not proctored, so there's no proctoring software. And it'll be open for a window for students to write in. Okay. All right, let's see. Identity. So will the quizzes be multiple choice? The quizzes could take many, the questions in the quizzes can take on many forms. So multiple choice is one of the possibilities. So some of the questions can be multiple choice. Some of the questions can be multiple select. So you have to select all the right answers. Some of them can ask you for code, right? So you have to write some code and then submit your code. Because Python is space sensitive, if you're asked to write code, you'll probably be directed to, you'll probably submit the code in an assignment instead of in the quiz. But we'll get around to that later on. How many questions will there be on the, I mean, it's impossible to say how many questions will be on the quiz because, I mean, it depends on the type of question. So, I mean, the quizzes are an hour long. So it's really hard to say how many questions will be there. Okay, identity. So identity is one of these weird things that turns out to be very important in a language like Python. Now, the funny thing is it's not very important right now because right now, all that you've seen for types are things like ints and floats and strings. And it turns out for those types of objects or those types, identity isn't very important. So you can get away without thinking about identity. But it turns out later on, identity becomes very important. And it also is very important in a language like Java, which you learn in CISC124. Okay, so in Python, if you write something like x equals 1, 2, 3, 4, or the 1234, what that really means is that, well, okay, so what Python does is it evaluates the right-hand side of the expression of the equal sign first. Right? So the x equals something is called an assignment expression. So Python evaluates the right-hand side of the expression first. So when it sees the digit 1, 2, 3, 4, Python knows that that is an integer value. And so what it does is it makes an int object representing the integer value 1, 2, 3, 4. Right? For now, so if you've read the textbook, you have an idea of what an object is, but for now you can just think of it as something sitting in memory, basically. Right? So it's something that occupies space in memory. Right? So it's this thing that represents the value 1, 2, 3, 4. And then the rest of the assignment statement assigns the identity or the memory address of the int object to the variable x, right? So in other words, this thing x is not the number 1, 2, 3, 4, right? So x is not storing the value 1, 2, 3, 4. Instead, what is stored is the identity or memory address of the object, right? And so in the Jupyter notebook that accompanies week 1, there is this analogy of your best friend named Maya. So there's Maya, the person, right? Maya's name, right? The name Maya is not the person, right? So when you say Maya, you mean you are referring, right? This arrow, you are referring to the person named Maya, right? And so in Python, when you say x equals 1, 2, 3, 4, right? There's some object that represents the number 1, 2, 3, 4, and the name x refers to that object, right? So the name and the thing, the object, are two distinct things, right? The two distinct things. And so what's possible is you can have two names pointing to the same object. So if you write y equals x, then y then refers to this int object, right? And so in the book, if you're reading the text, so you should be reading the textbook, you'll see these pictures where there are these names with arrows pointing to these boxes, right? And that's what they're trying to convey, right? The name and the object are two different things. And so what's stored in this thing x? Well, it's the reference to the object, or and the reference is just the memory address, right? And so if you were to go and look in memory and see what's actually stored for x, you would see a memory address. Okay. The same is true in Java for certain types. When you get to 124, you'll learn that there's two different types of things, two different types of data in Java, right? One of them looks exactly like this, right? So one of them is references. But things like ints and floats in Java don't behave like this. They behave differently, right? But for now, everything in Python, right, is a reference to an object, right? So when you write x equals the string hello, that means, right, evaluate the right-hand side. So make a string object or an str object that represents the string hello, and then assign the memory address of that object to the name x. Right, so again, right, x refers to some string object, and inside that string object is some data that stores the characters hello. Right, exactly how it works we don't know, and it's not important. Right? Somehow it stores the characters hello. Right, now when you write x equals y, right, what that means is assign the memory address of whatever y is to the variable x. Right, so again, x refers to, right, some object, and it's the whatever object that y refers to, right? So the type of that object is the type of y. Whatever's inside that object is whatever the type of y data is, right? If it's a string, it'll be some characters. If it's an int, it'll be some digits. If it's some other type, it'll be some other data. Okay. And so when you see an expression like x equals y plus z, right, Python tries to evaluate the right-hand side. So it tries to evaluate y plus z, right? Whatever that type is, assuming this evaluation is successful, right, you'll get an object of that type. So if y and z are both ints, you'll get an int object. If y and z are both strings, you'll get a string object. If y and z are both floats, you'll get a float object. Right? And if y is an int, z is a float, then the way it works in Python is you get a float. Okay, so you get a float object, right? So you end up making a new object of some type, right? And then you assign the memory address of that object to the variable x, right? So the picture looks like this: you get some object, right, whose type is whatever type y plus z is, right? Inside that object, there is some data, whatever data is associated with the type of y plus z. Right? Okay, so that's critically important that you understand that, especially when you proceed to next week and beyond. Right? So as soon as we start talking about things like lists and dictionaries and tuples and other types of objects in Python, this notion of identity and references becomes absolutely critical. Okay, so you have to be clear on what's actually happening in statements like this. Okay, anybody have any questions about that? Anybody? No? All right, if you have a question, type it in chat. I can't monitor chat and hands up at the same time. All right, good. Okay. All right, so if you are happy with the notion of identity, then we can move on. When we teach an introductory course in computer programming, there's a lot of arithmetic problems that crop up that people know how to do intuitively, but it's not always clear how you do these things in a programming language. Right? So one of these things is rounding to the nearest multiple of x. Right? So suppose you want to round to the nearest multiple of 10. Right? An everyday example, if you still use cash, and many people don't use cash, is when you pay for something in cash in Canada, everything gets rounded down to the nearest multiple of 5. Right? So there's a real life example where you have to round something. Okay, so the question is how do you do this in Python? Because Python's got this round function, but the round function only rounds to a nearest integer, right? So it takes some perhaps real value and then rounds it to or some float value, and then rounds it to the nearest integer, right? It turns out you can use that same function to round to the nearest multiple of some power of 10. Right, so there's a way to use that function to round to the nearest 10, or the nearest 100, or the nearest 1,000, and so on, and so on, and so on. Or to the nearest 10th, or the nearest 100th, or the nearest 1,000. Right, so round to 1 decimal place, 2 decimal places, 3 decimal places, and so on. But there is no function that rounds to the nearest multiple of, say, 5. So to do that, you have to write some code. Right, and the way you do this is, right, you take your number y, and you divide it by x, right? So that tells you how many x's there are in y, right? That's what division means, right? So 5, suppose we wanted to round to the nearest multiple of 2, right? And you have 5, you want to round 5 to the nearest multiple of 2. So 5 divided by 2 is 2.5, right? Then you round the result, right? So you take the 2.5 and round it. Now, in Python, rounding is a little funny. So the way rounding works in Python, if the number ends in 0.5, then Python rounds to the nearest even number. So 2.5 rounds to 2, right? In other words, it rounds down. 3.5 rounds up, so it rounds to 4, right? You may or may not have been taught that rule in high school. It turns out there's lots of ways to round. numbers that end in 0.5, right? You can always round up, you can always round down, you can round, or you can use the rule that Python uses, right? Round to the nearest even number. So 2.5 will round to 2, right? And then you multiply by x. So you'd multiply by, in this case, 2, right? So the number 5 rounded to the nearest multiple of 2 becomes 4. Right? Is this class curved? Is this class curved? Not by design. Not by design. Right, okay, rounding 99 to the nearest multiple of 5. Right, so you just follow this recipe here. 99 divided by 5, round it, right, multiply by 5. Right? Now, you should, in Python, when you come across these little problems like this, the easiest way to solve them is just to fire up idle and start trying things out. Right, so let's try that. Oops, sorry, Python. Right, and so it's kind of interesting that a lot of students, when they come to a problem they don't understand, their first instinct is to look it up online, and then if they don't find an answer, it's to ask a TA or the instructor. But you have to remember that this is a programming course, and you've got this interpreter, this Python interpreter, that you can experiment in. Right, so I would encourage you that your first instinct be, well, why don't I try something and see what happens, right? So, well, let's try this. Right, so let's round. Well, let's look at the example, right? So I want to round 99 to the nearest multiple of 5. So I know I should get 100, right? The answer should be obvious, right? So does that actually work? Well, let's see, 99 divided by 5 times 5. And it does, right? So that seems to work for 99. Now, what about 96? So 96 should round down, right? So let's try that. It should round to 95, and that seems to work too, right? And so this seems to work. Right? Now, in the Jupyter notebook, there's a question that says, that asks you the, oops, sorry. There's a question about rounding down to the nearest multiple of 5. Right. So we look at week 1. Hopefully this stays running because I'm going to need to begin in a second. But oh, sorry, I clicked the wrong one, didn't I? Week 1. And somewhere there is a question about rounding down to the nearest multiple of 5. Where is it here? Here. So you pay for an item using cash in Canada, and the price is always rounded down to the nearest nickel, right? So this is a slightly different version of this problem here. Right, this problem here rounds to the nearest multiple of 5, so it doesn't always round down. So here you have to figure out, how do I round down, right? So let's do. So we'll do our price is 99 cents. Right, now in this example, if you're paying cash, you only pay 95 cents, right? So you need to round down. So if I write 99 to price divided by 5, sorry, and then print result and run that, I'm going to get price divided by 5. Sorry, round. And then you run that, you'll get 100. Right, so that doesn't round down. So to round down, the easiest way to do that in Python is to use the floor division. Right, so // will give you only the integer part of the quotient, right? So it'll take price divided by 5, so 99 divided by 5, and it'll throw away whatever's after the decimal, right? So that effectively rounds down. right? And so you can do, now you get 95, right? There's also a function called floor in the math module that will round down, right? So that would be the other way to do it. Okay. Any questions about rounding to the nearest multiple? Anybody? Great. Wrapping. Okay, so there's another common problem that shows up in computational problems. And so that is you're dealing with numbers that are cyclic, right? And so the example most people are used to are seconds, minutes, and hours of the day, right? So the number of seconds in a minute is always 0. The number of seconds on a clock is always between 0 and 59 inclusive, right? The number of minutes in an hour is always between 0 and 59. The number of hours in a day is either between 1 and 12 or 0 and 23 if you use a 24-hour clock, right? And so those numbers are cyclic. The other example that many students are familiar with are degrees on a circle, right? So on a circle, you have 0 to 360 degrees, right? If you go around more than once, you just wrap the value. So here's an example where I have a cyclic range, 0, 1, 2, 3, 4, right? If you've taken calc, you should know that that's often written as a square bracket 0, comma 5 round bracket, right? So the range 0, right, up to but not including 5, right? So up to but not including 5. So here's my cyclic numbers: 0, 1, 2, 3, 4, right? And then they repeat, right? 0, 1, 2, 3, 4, and then they repeat 0, 1, 2, 3, 4, right? If you have the actual integer numbers, right, where 0 is here, then the actual integer numbers are -5, -4, -3, -2, -1, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on and so on and so on, right? And so it turns out there's a common problem where you need to take an integer value, right, and wrap that to a cyclic value, right? So the number 5 should wrap to 0, 6 should wrap around to 1, 7 should wrap around to 2, -1 should wrap around to 4, right? So -1 basically comes around to the other side, right? You get 4, -2 wraps around and goes to 3, -4 wraps around and goes to 2, and 1, and so on and so on, right? Okay, so this turns out to be a common problem. Anytime you're asked to manipulate seconds, minutes, and hours on a clock, you run into this problem, right? Anytime you're asked to manipulate angles on a circle, you run into this problem. And there's lots and lots of other examples that you can come up with where you have to deal with these cyclic values, right? And so the way you deal with this in Python is you use the modulus operator, right? That percent sign. Right? And so to wrap a numeric value to the range 0 to n, right, where you don't want to include n, right, you just use the modulus operator, the percent sign. Right? So again, in Python, you can play around with this, right? So let's use the range 0 to 5. So n is equal to, 0 to 5, not including 5, right? So the value 0 is just equal to 0, right? So if I do 0% n, I get 0, right? The value 1 is just 1, 2 is just 2, 3 is just 3, 4 is just 4, right? Now 5 wraps around to 0, right? And so that seems to work. 6 wraps around to 1, right? And so on and so on. Now -1 should come back to should wrap around to -4. Sorry, -1 should wrap around to 4, right? And that seems to work. So that's good, right? -2 should go to 3, right? And if you pick a larger value, you can convince yourself that that works too. And if you've been reading the week 2 notes and you've gotten to the loops part, you can just write a little loop, right? So for x, range, so let's do, I don't know, -15 to 15. Right. I want to do x percent n. There you go. Right. So minus 15 is 0, right? 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So there's 0. And there's 1% n, 2% n, 3% n, 4% n, right? 5% n, 6% n, 7, 8, 9, 10, and so on and so on and so on. Right? I guess if you wanted to make this a little easier to read, we can do this. X in range minus 15 to 15. Oops, sorry. Print x. Let's do something a little fancier. Print x plus x percent n. Oh, sorry. There we go. Sorry, that's not what I meant. One more time, sorry. I wanted to print the value of x as well. Print plus and then the wrapped value. Did I get all of them? There, one more, right? Okay, there you go. That's better. Okay, how do you enter a new line without executing in the command line? How do you enter a new line without executing the command line? How do you enter a new line without? I think you're asking how do you, so for things like loops, Zachary, when you put the colon in, the interpreter knows you're trying to write a loop, and so it will when you press enter, it won't actually execute the previous line. I don't know if control enter. I don't think control enter works. If you wanted to split a line, you have to. I guess you should just Google how do you split a line in the interpreter. Right. Okay. Right. So that wraps 0 to n. Now, once you know how to wrap 0 to n, you can wrap to any range. Right. So once you know how to do that, and that's easy, right? It doesn't matter what range you pick, right? So if you pick some range m to n, where m is less than n, right? It's simple, right? You just subtract m from x, right? So you make the range 0, right? So subtract m from both m and n, right? So wrap to the range 0, n minus m, right? Because we know how to do that, right? We know how to do that. And so you subtract m from the value x, right? And you wrap x minus m to the range 0, n minus m, right? And then you have to remember, well, I subtracted m to begin with, so I have to add it back, right? And so now your wrapped value is just x minus m percent, n minus m plus m. And away you go, right? And so again, you should fire up idle and try it out, right? See if it actually works. I've already done it. It does work. And play around with that, right? To convince yourself that, in fact, actually works. Right? And so those are the things I wanted to touch on from week 1. I guess now, I mean, everything else is in week 1 is unsurprising, I would say, right? So, you know, there's some arithmetic stuff. Arithmetic in Python is pretty similar to arithmetic in mathematics, right? So, you know, you have your operators, which you should be familiar with. It obeys the same order of operations, right? So sometimes you need to use brackets or parentheses, right, to control the order of operations. In Python, you can only use parentheses. Okay, so in math, you're used to using square brackets and braces. Those don't work in Python, right? Or any other programming language that I'm aware of. You always have to use the round brackets or parentheses to group expressions. Is there anything vastly different from CISC121 for week 1 and 2? Well, I've never taken CISC121, but I suspect the answer is no. I don't know if in CISC101 they really drove home the difference, they really drove home the notion of identity and references, right? So Mark, I don't know if that's the case, okay? Because I really don't know how much they discussed this notion of identity and references, right? You're going to find that week 3 is basically writing functions. And I know for a fact that in CISC101, you wrote functions, right? In CISC101, this notion of identity and references has a pretty significant impact on when you write a function, right? There are certain things you can't do in a function that you might expect you should be able to do, but you can't because of the way Python uses because of the fact that variables are in fact references in Python, sorry. Right, but Mark, you should not be surprised if there's a lot of overlap with CISC101 for the time being, right? Okay, does anybody, I joined late, what's the format for the quizzes? That's, well, I mean, the quizzes are on cue. They can consist of multiple choice, multiple select, short answer, and programming questions. Does anybody know standard? There's a discussion post about that, and also all of the videos that show you how to use idle talk about why standard I/O does not work. Standard I/O works in Python 3.8. It does not work if you're trying to do something in idle. But it certainly works in 3.8. So what doesn't work is if you're in the idle shell, right? And you try to import standard idle. It'll barf no matter what version of Python you're using, right? The reason it barfs is because the library standard IO uses this function right here, right? And that function right there does not work in this. Whoops, sorry. Does not work in the idle shell. And the reason it doesn't work is because the idle shell is what's called a fake terminal. And this function here only works in a real terminal. So you have to run it from the command prompt in Windows, or you have to run it from the terminal program in Mac. What is standard out? Standard out is this what's called the standard output stream. Normally it corresponds to the terminal that you're running in. Not everything has a standard out though. So if you're on a cell phone, for example, there's no standard out. Right, so standard out is, again, you can Google that and find all sorts of, and you'd find out exactly what standard out is. If you're running in a terminal, standard out is the terminal. Right. Yeah, I'll leave it at that. It's not the, there's a longer answer, but I'll just leave it at that. Do we need to use standard IO and CISC? Well, CISC is part of Python. So CISC turns out to be very important. Because it gives you access to the system itself, the runtime system. Standard I/O is, again, it's explained in the videos. Standard I/O exists because the book authors needed to make sure that everything worked in Python 2 and Python 3. And so if you want, you can replace everything. So anything standard IO.write, you can just replace that with print and not use it. Until which chapter do we need to read for end of week 2? So you should try to keep up. You don't have to. If you fall a little bit behind, it's not the end of the world, right? And I know it's actually quite a lot of reading, actually. So I think the first 2 weeks are very brisk, especially if you haven't programmed before. So what did I say? Week 2, I think I asked you to complete 1.2 if you haven't done so already, and then read 1.3 conditionals and loops. For the creative exercises, are they required? Excuse me, I find the wording confusing. Oh yeah, I forgot to tell you about it. The creative exercises. So I mean, you should attempt them. The authors of the book, the questions are very brief. There's not a lot of explanation. After I post the forums, I'll post a link here. Did I get the right one? No, this is Java. I don't want Java. I want the Python one. Sorry. Here. But if you click on these chapters, so for example, let's look at built-in types. A lot of the answers are here. Right. So even the creative, yes. So the creative exercises, there are some answers. Yes, I will send to the, yes, I'll post the link in the office. I keep on forgetting to do it. May I ask about solving problems in section 1.2 using coding methodology outside of the textbook? Outside of the textbook.
So Professor Ma, if I may elaborate on that.
Sure.
Point.
So what do you mean by that, Mackenzie?
So what I mean is that, as you know, I'm very new to programming, but I've been going quite smoothly through section 1.1, 1.2. As I was kind of... Hi there, can you hear me?
Hello?
Hi, can you hear me?
You can unmute if you want.
I can hear him.
I can hear. I can't hear him. Oh,
hi.
Hang on just a second. Oh, sorry, that's my cat. I wonder if my audio is working. Sorry, a second here while I figure out what's going on. Hello. It's supposed to be working.
Hi there, can you hear me now?
Can I show us? I might be able to show you one cat. I don't know if they're around. Hang on. Yeah, I can't hear you, Mackenzie. Sorry. My audio is not working at the moment. Can you type?
Sure. Okay.
Mackenzie, that's gonna be tough now.
Dude.
Who's here? Oh, that's too loud. Come here. Oh. Okay, to elaborate on my point. How many cats? I currently have 5. 2 of them are ours. We're watching 3 others because our cousin is moving. As you know, I'm new. However, that's good. Yeah, there's a lot of cats. I know. Well, the creative. Yeah, so the that is the one strength of this textbook. Is the big strength of this textbook. Sorry. Is that if you are mathematically / scientifically inclined, the exercises are very good.
Professor,
Yeah,
just wondering.
So, I mean, it's you're referencing coding methodologies outside of the textbook. I mean, that's good that you're doing research to solve the problems. What's important is, oh, I see. So I understand, right. Yeah, a lot of the exercises in 1.2, the natural way to answer them is to use an if statement. If you can, at some point, you should look at the answers and see to see how you can do it without using conditional. You're not. Are you undercutting your learning? You're undercutting your learning. I don't know if you're undercutting your learning. I mean, it would be unusual for someone to ask you to solve a problem and say, don't use a conditional. Right. I'm saying there are ways to use, there are ways to solve the problems in 1.2 without using the conditional. So I have pictures of the cat. I don't have any pictures of the cats on the computer. You might be able to see them if I turn on my camera. They're in the other room though. Hang on, let me grab one. Where? Oh. All right. Okay, hang on. I got a cat. I don't know how long she's gonna stay for, so just a second here. Can you see the cat? Oh, I have to probably stop sharing the screen, right? There we go. There's a cat. Whew. This is one of ours. Oh, there she goes. There you go. Off you go. Yeah, it's 1 of 5. All right. Will you be making recursive graphics in the course when we cover recursion? Yeah, we can do graphics if you like. Or, I mean, yeah, I'm sure the textbook asks you to do it too. But yeah, there are some interesting recursive pictures that you can make. But yeah, so that will be, we're definitely doing recursion. So we can definitely look at doing things like the Coke snowflake, or Sierpinski's gasket and things like that. So install Pygame. I think no. Well, I mean, the textbook asks you to do it. So in certain sections of the textbook and in certain exercises, it uses Pygame. You can probably, if you don't want to install it, you can probably get away with not installing it. Right? You just can't do those exercises. I'm not sure how active Pygame is these days anyway. It doesn't seem to have been updated in a bit. Well, are you willing to provide an overview of the dragon curve problem? Yeah, if you want. I mean, it's, I mean, that's, the dragon curve is pretty standard, so it's easy to Google too. Those cats can plan the end of the world. Yeah, it's true. It's true. I don't understand the concept of the dragon curve and what it is. I would ask you, so, I mean, for now, I encourage you to look it up. I mean, the very, very short answer is it's a structure that's defined recursively. But that won't make sense to you until we actually done recursion. I'm not sure if you have already answered this, but for quizzes and assignments, are we allowed to use print? Oh, yeah. Don't use standard IODAR, right? Quizzes and assignments, right? You should, if you need to print something, use print, right? Just use print. Is it a computing science concept? It's a mathematical concept. Do you mean recursion? Recursion is both mathematical. It's probably, I mean, it's a mathematical concept first, and then it turns out to be useful in computing. Dragon curves would have been studied in math before computing science. Okay. Any other questions? If not, that's all I have for today. Just keep on reading, keep on doing the exercises, and look out for the assignment coming out. It'll either come out late this week or on Monday next week. Okay. Oh, Cash, what's up?
Can you hear my voice? Like, is it audible?
If anybody wants to see another cat, I got another one. Well,
no, man, he can't hear you.
This is the
His audio
cousin's
doesn't
cat.
work.
Oh my god.
This is one of 3.
Yeah,
Say
you're gonna
hi.
have to type. This
This is
is
Ivory.
time to test out your words per
There.
minute.
Okay, off you go.
I'm going to break my laptop. I'm not shit.
How long are the assignments? Hard to say. The first one will probably be, it's hard to say. The first one's probably shorter. Well, it's probably shorter for many of you. So for anybody who's taken CISC121, the first assignment, it should be relatively straightforward, right? Because it's basically is going to involve the material in weeks 1 and 2, maybe 3. Can you give an example of an assignment question? Not easily. So assignment 1's different because there's a lot of concepts that should be that I need to make sure students are familiar with. And so assignment 1, you shouldn't be surprised if it's just a bunch of small questions, right? Write a program that does blah, write a program that does blah. So you shouldn't be too surprised if it's like that. The later assignments, so I typically like to ask assignments that build to something, right? So, I mean, in CISC124, for example, last term, their first assignment was write some methods that help you solve a Sudoku puzzle, right? The next assignment was Boggle, right? So the next assignment was write a bunch of classes that let you play the game Boggle. No, or was it the Turtle? I think it was Turtle. So there was a write a class that lets you draw pictures on the screen using something called a turtle. And then assignment 3 was basically write the game boggle. What was assignment 4? Assignment 4 was, well, assignment 4 is not important. Is there an outline or a rubric for the assignments? Not yet. Not yet. Normally, I mean, this is a programming course, right? So the rubric is more or less is what you wrote correct, right? And has it been done with good programming style? I asked the TAs, but even they can't figure it. Oh, sorry, Cash. Where did you go? Oh, here it is. CISC path insert. This is, oh. Really? Is it in the Jupyter notebook? That didn't work. It should work. Just don't. Oh wait, I have to reload the notebook. Hang on. Boom, boom, boom. Are you running the notebook locally or online? I thought it worked. I thought I checked it. It worked. It should work. If not, it's a typo somewhere. Does anyone know what Google access the solution? Yeah, I'll post Mackenzie. I'll post the link. Here, right? Does it not work? It works. Cash, I just ran it.
He just hit you with the
I wrote
user
it
error,
wrong
bro.
somewhere else. I do remember I had to fix it at one point in time because I did have the wrong thing. Do I use it somewhere else?
Your WhatsApp thing.
I don't think I use it somewhere else. Here? Is it different? No, I think it's the same. Yeah, it works. Oh, sorry, Cash. There you go. This one. There. So here, let me cell pair output. Okay, so this is actually running online, right? If I run this, it works. If I run this one, it works. I'm using Jupyter Notebook app. Yeah, using the Jupyter. So you are running it locally on your computer? Is that right, Cash? Yes. Okay. And you cloned the entire repository? I downloaded it and tried to run it. It should work because it runs. I mean, hang on. So there is something. If I didn't upload the repository to GitHub, that would explain it. But I'm pretty sure it's here. So yeah, it's right there. It's here, right? Yeah, everything's here. It should work. I mean, it runs on my computer. I know that for a fact because I wrote it on here. So, oh, hang on. Okay. One notes. Jupyter. Okay, so this is the notebook running on my computer here. Start here. Week 1. I mean, if it works online, it's got to work here. If you clone the entire repository, it should work. Yeah, it works. Any other questions? Cash, if you want help with it, you drop by office hours when I get my speaker or my sound working again. Let's do it during office hours tomorrow. I have to wrap this up, and then I have to do 124 in an hour. Way able to explain the difference between assigning command line arguments using CISC-argv1 and inputs split for manipulating a string. Manipulating a string. Or is that too far advanced for where we are now? I mean, it's not too far advanced. Input split. So input split is going to input split.
He gotcha, bud. He gotcha.
Input is going to read from the terminal. It's not a command line argument. Right. So when you ask for input, the user has to type something in. So the program starts running and then you type something in. Right. Command line argument, you pass the arguments in when you run the program. Right. So they're actually two different things. Okay, anything else? So if I print the command line arguments, I use the string from that print. If I print the command line arguments, I use the string from that. Not sure what that question means. If you use the command line arguments, you are getting the strings from the command line, right? So you're getting the strings from when someone types. So for example, this isn't going to work because I don't have a Python file here. 1, 2, 3. So you'd be getting the strings 1, 2, 3 from here. Input split's different. That's you're writing a program and then you are going to get the inputs. I was trying to use CISC argv. Yeah, I mean CISC argv is fine as long as you run your program like this, right? There's I think the video for Windows users. I think the one for Mac users shows you how to do this too. Right. Sorry for me. Yeah, I can understand. Sorry about I don't know what's going on with the sound. Everything looks like it's set properly. It's just not working. Sorry. Do you mind dropping by office hours tomorrow? Or we can do it then. Okay. Anything else? I should get going because I have to start 124 soon. Oh, you can't. Email me and we'll schedule another time, Mackenzie. Okay. Last time, anybody else? All right, so I'm gonna stop recording and I'll leave the meeting and post the video in a couple hours. Okay. All right. Thanks, everybody.